All right, so in this part, starting with number 6, we're going to pick up with simplifying the trig expressions, not just the factoring. I know that factoring is simplifying, but we're going to use some other strategies besides factoring. So looking at number 6, we got a cotan x over cosecant x. Now, one of the strategies for simplifying or verifying is to rewrite everything in terms of sine and cosine. So looking over here, we got cotangent of x. Well, what can we do to substitute in for cotangent of x using sines and cosines? Well, if you recall in the identities that tangent is equal to sine over cosine, and cotangent would then be cosine over sine. So that's your quotient identities. So up top here, I can go ahead and say that this is equal to cosine x over sine x in my numerator. Well, then in the denominator, I have cosecant x, and if I use the reciprocal identity, that is equal to 1 over sine x. So now I have a complex fraction here. I have cosine over sine divided by 1 over sine x. Well, what can I do? Remember, if you're dividing fractions, in essence what I'm doing here, I can flip the second and multiply. So then this would become cosine x over sine x, my top one right here. So if I'm going to flip and multiply, times sine x over 1. Take the bottom one, flip it, and multiply. So then when I look here, what I could do is I can reduce those, and that would just leave me with cosine x. So that is my simplified answer for cotangent x over cosecant x. All right, let's look at another one. So we have cosecant x times tan x times cosine x. So again, looking here, we got cosecant times tangent times cosine. One of the strategies is to just go ahead and rewrite everything in terms of sines and cosines. So let's go ahead and do that. So cosecant x is equal to 1 over sine x times tangent is sine over cosine using the quotient identity. So sine x over cosine x. And then of course we just have cosine x. So you could go ahead and multiply straight across here, or let's just go ahead and simplify. So I have a sine x in the top and the bottom here, and then I got a cosine x in the top and the bottom, which just leaves me with 1. So that whole expression is just equal to 1. All right, let's take a look at another one. So we got sine squared x times secant x times cosecant x. So again, working on this same strategy, we're going to go ahead and change everything to sines and cosines. Well, we already have a sine squared x, so there's nothing to change there. Times, I'll put this over 1 to line everything up. Secant, the reciprocal is cosine, so 1 over cosine is going to be the identity. Times, and then cosecant, again, would be 1 over sine x using the reciprocal identity. So now from here, if you go ahead and you can multiply this all the way through, or you can reduce if you want to, because you see you have a sine squared x and then you have a sine x. So if I get rid of 1 here, I get rid of 1 here, it just leaves me with sine x and the cosine in the top. So sine x over cosine x. And then looking at this right here, if you look at your identities, going to your quotient identities, you will see that sine x over cosine x is equal to tan x. Now, changing things to sines and cosines to simplify doesn't mean that the answer has to be in terms of sine and cosine. You're just trying to get the simplified version of your expression. So while you change things to sine and cosines, we'll help you to do that. Sometimes, like in this case right here, sine over cosine, we're going to change that back to tangent. That's the simplified version. All right, so looking at number 9, we got cosine squared x times secant squared x minus 1. So as of now, we've been doing just changing everything to sines and cosines and working with that. Well, looking here, you can see secant squared x minus 1. Hopefully, if you go to your Pythagorean identities, you can see that secant squared x minus 1 is equal to tan squared x. So that is another strategy, is manipulating the Pythagorean identities when you are simplifying a trig expression. So I'm going to go ahead and replace a secant squared x minus 1 with tan squared x. Now I can go ahead and switch this to my sines and cosines. Remember that tan is equal to sine over cosine, so tan squared x is equal to sine squared over cosine squared x. So I get cosine squared x, and then I'm going to go ahead and put in my identity, so sine squared x over cosine squared x. And then hopefully recognize, if I put this over 1, make it a little bit easier, that you can reduce those, and that just leaves me with sine squared x. Now, there are different ways that you can do these problems and still be correct. Some of you might right off the bat say, hey, I'm going to go ahead and distribute this. So I'm going to take a look at that and show you that you would still get the same answer if you do that. So if you went ahead and distributed this, you would get cosine squared x times secant squared x minus cosine squared x. And then some of you would say, all right, well, I'm going to go ahead and change everything to sines and cosines. So I'm going to go ahead and change this to 1 over cosine squared x using the reciprocal. So cosine squared x times 1 over cosine squared x minus cosine squared x. So if you went ahead and multiply these, let's move this up a little bit, that would just give you cosine squared over cosine squared. So of course that's just going to reduce, and that leaves you with 1 minus cosine squared x. And then of course, if you go to your Pythagorean identities, you know that 1 minus cosine squared x is equal to sine squared x, which of course is the same answer that we got up here. So again, there are different ways that you can go about simplifying these problems. As long as what you're doing is correct, then it's fine. So let's go ahead and take a look at number 10. So number 10, we have 1 minus cosine squared x over tan x. So I'm looking at this problem and I'm thinking I'm probably going to go ahead and look at my Pythagorean identity, and then I'm probably going to want to go ahead and change this to the sine over cosine. And that's exactly what I'm going to do. So 1 over cosine squared x is equal to sine squared x, again in your Pythagorean identity. So I have sine squared x over tan is sine x over cosine x. So now, like we did in the other problem, I'm going to go ahead and flip this and change it to a multiplication. So when I do that, that is going to be sine squared x times, flip and multiply, so cosine x over sine x. And then I can go ahead and reduce one sine in the bottom, one up in the top, and now that's just going to leave me with sine x cosine x. And that is the simplified version for this answer. All right, you can get one more in here. So look at number 11. We have secant squared x minus 1 over sine squared x. So again, I look at the secant squared x minus 1, I'm thinking Pythagorean identity. And when we know, if we look at the identities, that secant squared x minus 1 is equal to tan squared x. So I'm going to go ahead and replace that. So I get tan squared x over sine squared x. Now what else can I do? Well, tan is equal to sine over cosine with your quotient identities. So tangent squared is equal to sine squared over cosine squared. So I'm going to go ahead and do that. So I got sine squared x over cosine squared x divided by, I have my sine squared x. So now, of course, we have this complex fraction, so I'm going to flip this and multiply if you want to put this over 1 to make it easier. So when I do that, it's up a little bit, I get sine squared x over cosine squared x times 1 over sine squared x. And then, of course, we can go ahead and reduce. I have my sine squared over sine squared, which leaves me 1 over cosine squared x. And then we can go ahead and say that is equal to secant squared x. And that one is finished. All right, so looking at number 12, so we got cosine of pi over 2 minus x over sine of pi over 2 minus x. So hopefully when you see this, you're thinking cofunction identities, and that's exactly what we're going to do. So cosine of pi over 2 minus x, that is equal to sine x, and then sine of pi over 2 minus x is equal to cosine x. And then, of course, sine x over cosine x, looking at your quotient identities, that's going to equal tan x. And that one is simplified. So looking at number 13, we got secant squared x minus tan squared x. Now this, I got a bunch of options here. I can go ahead and use a Pythagorean identity to replace tan squared x. I can use a Pythagorean identity to replace secant squared x, or I can go ahead and switch these over to sines and cosines. So I'm going to do all three just to show you how you can go through the same problem 3 different ways. So I'm going to replace, for the first one, I'm going to do tan squared x is equal to secant squared x minus 1. So if I go ahead and do that, secant squared x minus, and then replace tan squared x with secant squared x minus 1. And then, of course, I got to distribute that minus sign. So secant squared x minus secant squared x plus 1. And then secant squared x minus secant squared x, that just becomes 0, and I'm left with the 1. All right, so now let's go ahead and replace secant squared x with tan squared x plus 1. Let's use that Pythagorean identity. So that's going to be tan squared x plus 1, replace, minus, I still have the tan squared x right here. And then, of course, tan squared x minus tan squared x, that goes away, and that just leaves me with 1. So that works out. A little easier too, one less step. So now if I go ahead and replace everything with sines and cosines, so secant squared x is equal to 1 over cosine squared x, minus tan squared x is equal to sine squared x over cosine squared x. So now looking at this right here, I'm subtracting fractions. I already have a common denominator. So I can go ahead and just write this over the common denominator. So 1 minus sine squared x over the common denominator. And then, of course, we know using the Pythagorean identities that 1 minus sine squared x is equal to cosine squared x divided by cosine squared x. Hopefully you see where this is going. Cosine squared x divided by cosine squared x is equal to 1. So you can see I had the same problem. I did it 3 different ways to get the same answer. All right, so let's look at the last problem for this part of the video. So number 14, we got cosecant squared x minus 1 over cosine squared x. So looking here, I'm going to go with my Pythagorean identities. Cosecant squared x minus 1, that is equal to cotangent squared x over my denominator, so cosine squared x. And then I'm going to go ahead and replace this with your sines and cosines. So cotangent squared x is equal to cosine squared x over sine squared x divided by, then I have my denominator, so cosine squared x. I'm going to go ahead and put that over 1 to make it easier, because I'm going to go ahead and flip this and multiply. So that would give me cosine squared x over sine squared x times 1 over cosine squared x. And then, of course, we can simplify. So that reduces out, which leaves me with 1 over sine squared x, and then 1 over sine squared x. Finally, we get to the simplified answer, which is cosecant squared x. So we'll pick up with number 15 in part 3 of the video.